stop us now. Together we'll redefine the game. With NEAR we'll fan the flame. Empowered minds rise and soar. Use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Hello. Hope everybody's having a great time. We are joining again for the latest installment of our AI office hours. I'm really excited to have Jason Warner here. I'll let him introduce himself, but I'm sure going to have a very interesting conversation. Jason, introduce yourself and kind of tell us more what you're working on right now.
All right. Thanks, Illia. Thanks, Alex. I did not realize you had 20 episodes of these things. This is pretty cool. Everybody, I'm Jason. I'm one of the co-founders of Poolside, Poolside.ai on the internet, which basically says nothing about us at the moment, but give us a day or two and it'll be out there. Prior to Poolside, I was the CTO at GitHub for 4 years. So 2 years pre-acquisition by Microsoft and then 2 years post. Prior to that, kind of the same thing at Heroku, which is a platform as a service now owned by Salesforce. And before that, same thing at Canonical. People make Ubuntu Linux. So I like to say that it's a long-winded way of saying that I am very, very useless in a desert island scenario, but if it has a keyboard attached to it, I'm okay.
But overall, you've been kind of hanging out around developers for a long time. That's pretty much the...
Yeah, I mean, developers are fun, finance people bad. No, not my thing. So this will be a fun conversation here.
Yeah. So I mean, I don't know how much you want to share about Poolside, given your background and context, but it's probably going to be valuable for the conversation.
So for the conversation, Poolside is essentially a continuation of conversations that I was having when I joined GitHub. So when I joined GitHub in 2017, again, 2 years before the Microsoft acquisition, I wanted to turn GitHub from a code host into a software development platform and infused with intelligence and like long, drawn out plans and all that sort of stuff. But the continuation of what Poolside is kind of like going back to that original vision to a degree, which is that software development and neural networks and the marriage of those two things are going to be monumentally beneficial for humanity and developers. And we're pushing that boundary forward. We're pushing all of those things over there. So GitHub Copilot, which was incubated in the office of the CTO while I was at GitHub, is a slight divergence from the original view that I had and my co-founder, Iso Kant, who I met when I was at GitHub, had at the time. And Poolside is kind of going back to it. And very specifically, what that means is we're building a foundation model from scratch for software development, where you have a couple of different proprietary techniques. The one that we've become most known for is this thing called reinforcement learning via code execution feedback, which we can get into here. But the idea being that we're going to advance software development via these mechanisms very quickly over the next couple of years.
Yeah, so I guess it's relevant within the context, obviously, of what we've been doing, and that's been part of the conversation we've been having for past a while. But yeah, I think we all agree here that AI development is kind of the future.
Yeah.
And there's going to be probably a pretty rapid transition from kind of individuals writing code, and kind of needing big teams to actually facilitate big projects, to kind of more and more periphery being built by AI, and then kind of architecture, orchestration, and kind of definition going in that direction. We see some of these examples already. Obviously, for us, it's been interesting because in Web3, there's just not many developers. And so like even, and the kind of code bases in general are pretty small. So you can do a lot more things from scratch. I know you guys are working and kind of aiming for work with like larger code bases and really giving a leverage there. So I'm curious how you see this trade-off of, helping existing developers working, being more productive, or kind of leapfrogging that and just giving non-developers ability to build software from scratch, kind of not even trying to operate on legacy code.
Yeah, I mean, I think like there's a couple of different ways that you could look at this, but from a capabilities perspective, I think making let's just bucket them as greenfield, brownfield for now, like those two categories. Greenfield's always, in my view, going to be easier to go do. And this is kind of like a lot of like what Heroku even started as. Heroku was brand new project from nothing, get it to launch, get it to out there. The challenge you have when you're doing brownfield things is you have a lot of history and cruft to deal with in many of these situations. So our view has been that we want to affect every developer in the world, every line of code, that sort of thing. The hard version of that, in our opinion, is to go through enterprises and brownfield applications. So that's why we're doing that. We think along the way, we will advance all of software, and there'll be many different versions of advancing all of software as well. So like Devin is a good example of something that has started to exist in the world, a different view on an interface into software development that could be. And so two things here from our perspective is I think that all of those experiments are worth it. Whether it's going to be how you're going to use agents in brownfield or agents in greenfield, or you're going to do all that work. And then the other is going to be, what do you want to do as a company? And our view here is going to be that we want to power all those experiments. So, the Devins and Cursors and Zeds of the world, we want to power those. So new editors, new ways that people are going to try interfaces into software development, want to power those. And then we will have our own opinion for our core customer base, which is where we build our own applications on top of our model.
Completely tangential question, but what is the greenfield and brownfield?
Well, it's typically to say greenfield is the brand new applications from scratch, and the brownfield ones that you're kind of migrating or helping people navigate. A lot of stuff with Git history or something like that. By the way, I do need to call out, I find it very funny. If ISO was on this call, we might have the totality of people in 2016 and 2017 who felt like they cared about AI for software development. With you guys in NEAR.AI at the time, and ISO with Sourced, and me trying to find anyone in the world that was doing this, and it was just basically NEAR.AI and Sourced at the time. I find that to be really amusing.
There was a couple more. There was this Zurich team, and then there was Microsoft team. But yeah, Ada was one of the few people whom we ran into back in 2017.
Not a lot of people in the world cared about it at that point. We're thinking about it to the degree, because you guys are like the OS of OGs in a couple of different spaces. So
yeah, well, I mean, this is partially where we bonded with Alex, because both of us tried to do this somewhere back in the day. I was trying to actually do it for my bachelor degree, but I realized that I will end up with nothing on my bachelor degree, and so end up doing something else. Yeah. So.
Yeah, same story. But going back to Poolside, right? So you mentioned that you guys training your own foundational models. Obviously, like the first question that everybody probably wants to be answered when they hear that is how do you see it relative to like fine-tuning 405B, right? Because if you have reinforcement learning from execution, which I would also be interested to learn more about, but that sounds like something you can do on top of a pre-trained model that is somewhat capable, right?
Yeah, I mean, the general view that we have is that let's just put the whole AGI wrapper on the top of this too, is that you have to have two different views. One is if you're building a business to make money for yourselves as founders, or if you're building something that's going to exist long term. And like the way that we've wrapped our entire company from the beginning was, where SpaceX, we need to build a Starlink inside of it. So SpaceX is that grand long-term mission and vision. And if you have that grand long-term mission and vision, you're going to go do certain sets of things that just you need to go do. And our view is going to be that you couldn't build an AI company in a SpaceX sort of way by fine-tuning your way to that. You had to own your own foundation model to a degree. Now that's, people are going to disagree with that proposition, but it would be the equivalent of Elon saying like, well, I don't need to go build rockets. Essentially, I can use somebody else's rockets to do that. We don't hold that view. And I think that, fine-tuning any of those models is a perfectly fine approach to building a business. It's just wouldn't have been for us. And then from a capabilities perspective, you have to ask the question, and this is one that I hold, really close, which is how open is it? Illia, you and I have had this conversation in private many times about what that looks like. But I also don't think you can serve enterprises by building on top of those models because of choices that they have made about their data and how open they're going to be with the data side of the fence as opposed to the weights. And again, I was in the room for a lot of the writing of various open source licenses, and I still hold the view here that if you're not opening your data, you're not open source on the model side of the fence. And I'm just going to keep saying that. And I know it's not the popular opinion, and people want to say that as long as you have the weights, you're open, but I don't think that's true.
I don't think I think the former is the more popular opinion if you go to Hacker News. After every
Hacker News is more like us, and then Twitter is like maybe a different variety of things. So and I think, again, incentives rule everything around us. So I think the people saying one side of the fence are incented to say that giving the weights are open.
Well, I think it's pretty much until there's like a fundamental bug in the weights, and then you're like, what do we do now, right?
or as Illia, you and I have talked about in the past too. I think Alex even had it over breakfast one day, but it was until somebody also has some sort of a really big security issue or data breach issue with the pre-training data. And I think most people who are new to the space don't quite understand that side of the fence yet. And because it's not in as an example, Meta's best interest to be open about that, they're not going to be open about that.
So for reasons that were wrong, last year I was involved a lot in training foundational models, and a couple of things I learned for myself is that the existing infrastructure that is in open source is not adequate to train them fast.
Yep.
Right. So I guess flash attention exists, but beyond that, everything else is sort of slow, right? Like relative to, I guess. The number that everybody has, right? So I have some alpha from my short stint at OpenAI in 2022, but there's also a number that is publicly available, which is in the Llama paper. They say how quickly they were training Llama 1 7TB, right? So this is their old code base, right? And that was very fast, right? Way faster, like several times faster than what you would get with PyTorch, right? So I guess to train your own foundational models, you either spend more money by using what exists, or you need to bring people who can write CUDA kernels, right?
Yeah.
So which of the approaches you guys taking?
So I will generally say this, which is there's two ways to look at everything you're doing in foundation model training. You're basically getting more data efficient, more compute efficient. And our view is you got to get better at both. So we have an entire pre-training team of some world-class exceptional people who are doing everything on that side of the fence from scratch, from the ground up training. So again, it's like not using off-the-shelf anything. And Alex, as you painfully observed too, like if you can't control that side of the stack, you're not really in control of it. Going back to the rockets analogy, even so far as to say, like, if you're using somebody else's model, you're using somebody else's rocket. But if you're using something off the shelf, you might be using component parts of the engine as well. Well, again, going back to the SpaceX analogy, you got to build the whole thing to a degree. Now that's a dicey proposition for startups. It's really difficult to go do. And, but we've taken the view that we had to go do that. And the first decision as an example was not one of the first sets of decisions was we're going to build our own pre-training stack. And so we have people who are doing all of that. We have people who are working on CUDA kernels as an example. And we have people who are doing the entire pre-training stack. And yeah, it's annoying and it's often frustrating at times because this stuff, if you know what I'm about to say, half the stuff is hiding behind private APIs at times that you have to like work with vendors on, and it's really annoying.
Yeah. But there is no plan to open source those kernels, right?
We're going to open source certain things. We're just not 100% certain exactly what we're going to open source yet.
Yeah, because one thing that Illia and I are coming back to is that ideally we would have tier 1 open source foundational models be truly open source, right? And so then we would need the whole training loop built in the whole data preparation loop. So that was the second. That would have been my second question, but you answered it, right? That besides the kernels, you need data, and the cleaning up data and preparing data is very hard, especially given that
the whole pre-training team that we have is spectacular. The whole data team that we have is spectacular. And then the first 2 hires we had in the company outside of ISO myself joining, whereas someone working on the training stack, someone working on the data pipelines and data cleaning and processing and all that sort of stuff. But we talk about this. ISO and I talk about this is where we will and won't open source some stuff, because we have to think about what is near-term advantage versus long-term. So as an example, we've trained two models at the moment, or it's a family of models really, but we're going to bring them out to the world as the large language model, the chat model, and then the code completion model. And the code completion model is a different architecture. We've been experimenting with it for about a year now, and we're going to bring it live. But it's still an advantage for us to keep that proprietary right now. So we're going to keep it proprietary. The world will catch up to us on this at some point in the next year, and then we'll probably open source the foundations of those things there. So we've not settled on our strategy just yet, what we're going to do here.
Yeah. I don't know if now would be a good time to dive deep into RL. How do you abbreviate it? RLCE?
Yeah, so ISO named it, and that would mean that since we're both engineers, we probably should put some marketing clout behind it, but we call it RLCEF, so reinforcement learning via code execution feedback. And the simple thing here is it's patterned after AlphaGo, essentially, like all the learnings that we had from AlphaGo on what made that so successful. We're trying to apply those same things to software. And the simplest way to say it is that software, for whatever percentage you're about to attribute to this, and I'll say, hey, it's 95+% deterministic, and we're going to take advantage of that property in software and use that to our advantage. So effectively, how to describe it at the highest level is we download tens of thousands, scaling up to hundreds of thousands this year, projects, open source projects. We make every Git commit in them executable, and then we ask our models to complete the tasks. We run them in our environment to reward them. We do it not just once, but many times, so we can do positive and negative sampling inside there. And two things come out of that. One is obviously that's a learning, but two is that becomes synthetic data for us. So the whole environment here is obviously decently complex. It's a massive runtime environment, but this is how we further train our model, as opposed to just taking data off the internet and sending it through and learning from that.
So what is so you download the GitHub repo, right? But how do you choose? But like I think the most interesting part here is how to choose the task to evaluate on, right? Because in order to give positive reward, you need to know what is the correct output, right?
We're not gonna give all of the details on that one, because that's also going to be some R alpha here. So, but I would say that we have a way to identify what are really good candidate tasks here, and it's not just like coding tasks. So it's not just like add function or change or write test or whatever. It's like it's a host of things under the umbrella of what software looks like. But we have a way to identify a set of tasks inside of there, because you're going to use different heuristics. Like one is it's got to come from a high quality source. So high quality code base written by high quality human. It's got to pass a certain set of heuristics, all that sort of stuff, from a positive perspective. And then we also have to judge our own as the model produces the tasks, the samples themselves. We've got to model those. Not just does it pass all of the different heuristics that would say, yes, you did the job successfully, but you're also going to grade it, saying even like, let's say you do it 20 times. 17 of those fail, so obvious on the failure case, then you can start grading them, but 3 of them pass. You want to know which one is the more optimal of the 3. So you then have to start doing things on that side of the fence as well. So this is kind of like where our secret sauce is, but I'll just say that we have a way of grading, and it's in figuring out which tasks to go do. I would also say that this is something where we invest a lot of time and energy, because this is where we're going to get a lot of our own value in the future. And as we scale this up to doing not just tens of thousands, scaling to hundreds of thousands of repos and projects this year, but to let's call them, those are millions of tasks. Let's call them tens of millions to hundreds of millions of tasks in the next year.
Yeah, this is. Go ahead, Illia.
No, it just maybe relevant comment here is what this really means is that you're going from kind of some amount of data, your synthetic data set is actually way bigger. and so you actually like scaling up the amount of
Yep.
like data that you can actually use.
So let's just use some like numbers that we've seen, and like again, like who knows, right? Like, but all of us in the AI world effectively have, like, the dirty little secret being that we effectively have access to the same data. We're all pulling from the same public sources. And unless you're using gray market data, which we know that some are, but let's just say that you're not, you're just using publicly available data. You've got something like, let's just call them 30 trillion available tokens. I think it's actually 50 if you 50 trillion tokens, but you move down to like high quality data that you should put in there. Let's just call it 30 trillion or something like that. Well, of that 30 trillion, about 3 trillion of that is code related data. We project that we will generate on that order of magnitude of code data in less than 2 years. So the equivalent of what is available publicly will generate from this approach.
So you're saying on that order, you mean on the order of 3 trillion or 30 trillion?
3 trillion. So
you will double.
Yeah, we'll double it. Now, obviously that like time, projection. And so what we say very publicly is that somewhere in the order of like 1 to 3 trillion. But it doesn't really matter if you think about it from that perspective. What Ilya was saying is true, which is even if it's a third of that and it's a 1 trillion, like, well, if there's only 3 trillion available, like this, the quality of our data is high because of the approach that we take, but just the availability of the data is enormous. And this is the kind of the holy grail that everyone's after. And as we're all kind of talking here, the other side of the fence is everybody's trying to do this. Everybody's trying to do it, but a lot of folks are trying to do it on language, which is, one, it's like easier to do but harder to judge because it's non-deterministic. So it's easier to generate synthetic data, but it's harder to judge, and you end up with entropy problems inside of that side of the fence pretty quickly. On this side, it doesn't appear to be we're going to end up with the entropy problems. It's just harder to build a system that can go do this in a quality way, but it's also easier to judge because it's deterministic. So we have advantages that we're trying to take advantage of in software to go do this.
Yeah. I find it interesting that there is multiple. So now, like with your story of building this RL CEF, it would be the third example in the recent history where someone came, said, guys, we're doing like interesting RL. I don't know if you guys using any tree search or like if it's more linear, but like OpenAI was like, well, OpenAI didn't want to say that, but someone said OpenAI is doing Q#, and Q#, everybody like that must be tree search. Right? And then
I'm not going to say anything, but it's yes.
I see. That is something that's not anything, but
yeah.
And DeepMind came and they're like, hey guys, we're doing like alpha proof, and alpha proof is a tree search in the space of lean programs. And then you guys doing tree search in the space, like based on the execution feedback. And I find interesting that in all three of them, like as a, any person who is into machine learning, the first thing people do is they go to the whiteboard and try to, like how would I do that, right? And in all three examples, like my personal journey ends, getting stuck with figuring out which data to use, and specifically not even data to enroll, but the data for the feedback, for the actual reward, right?
Yeah.
Like if you do Strawberry, right? I look at GPT-4o1. I'm like, yeah, maybe like I'm pretty certain that tree search is very sophisticated and built by the brightest minds. But even before we get to the tree search, how do they choose the reward, right? Like if it's
this, it feels like everyone kind of like gravitates to the same set of things. Like we're all kind of in the same park, if you will. And then we all end up similarly, like there's a major problem to be solved to see and be able to explore the next park. It's like a locked gate, and we all kind of run up against it. I usually typically have started to work backwards, and the team that we have here, some of the best on the RL side of the fence, kind of in this domain, cared about this for quite some time, either from DeepMind or other places. And the way that we work backwards is what would it take to do what I call full program synthesis in the future? Like if you were to use a system like this to automatically write full programs, how would you theoretically use it? And you could kind of work backwards from that to determine, and then you end up at the exact same spot, Alex, that you were talking about, which is like, okay, so which data set do we use and how do we do this and how do we scale it? Because it goes back to the bitter lesson, doesn't it? And it always does go back to the bitter lesson, which is, hey, more compute solves a lot of these problems because you can search through these things quicker.
But I think like your Alex question is, yeah, what would be the seed data? And the answer is like it's a function of existing data that's already there that you permutate in some ways to create kind of candidates.
Yeah, and then the idea here would be too that you're not creating a singular, you would try to be creating multiples, and then they would fail spectacularly, some of them at certain points. You're like, yeah, that's just wrong, right? But again, taking advantage of software, you can actually deterministically get to this point quickly in some scenarios because one doesn't compile or it's syntactically wrong, won't run, or there's errors and things of that nature, plus a host of other things. So again, it's not just a theoretical problem. You can actually practically put it into an environment and start testing some of those. So, if you don't necessarily have the right answer, you can at least send it through something and say like, okay, so we didn't have that perfectly mapped out, but we can also short circuit what we don't know at the moment.
I'm curious. So one of the kind of interesting things, right, with scale, right, we see the capabilities are growing, but it's still like clearly missing some conceptual things about, algorithms, about some of the relationships between entities. Kind of how are you looking at that? Like, is it just like, let's just scale and build a bigger model and hopefully it'll figure it out, or kind of you are thinking about it in a more nuanced way?
I would say that, we're an applied research group. So kind of going to computational and data efficiency, we're more focused on the data. We're making everything computationally more effective for training in the current approaches, and data from a data efficiency, data usage perspective, and data generation perspective. We kind of went into this. At our current stage, I wouldn't say that we have a dedicated research group saying what comes next from an algorithmic breakthrough perspective. And that's a function of scale and where we are from our own maturity perspective, but it is something that we have to invest in the future. And obviously it'll start with, let's just say, dedicated research more in like the domains that are applicable to us right away. And we have already the applied version of that. So RL would be a good spot for us. But kind of like the classic breakthroughs that, obviously Illia, we're talking about here in that way, we're not set up for that at the moment, but we do need to in the future. It's just that comes with a function of success. So the more success that we have from a business perspective, the more we're going to invest in there. But our primary, and you got to think about what matters from a focus perspective as a business at the moment, there's only a couple of things that we need to focus on right now to earn the right to even be able to do that in the future. And this goes back to my bad SpaceX analogy, but it's very simple. Like, I look at it this way: our ambitions are X, like our ambitions are SpaceX, to explore the universe, colonize Mars. But right now, we also need to build a massive economic engine to fund those ambitions. And so that's our Starlink. So we're very much focused on the Starlink side of the fence. Like, we need to make enough money to go further the ambitions. And so, we don't have that mega philanthropic donor giving us $10 billion to go unbounded compute type of scenario. So, but in the future, very much so. I think it's needed. I think it's absolutely needed. And I think also you need another thing that we need more compute diversity. We have effectively one mega company where we can get all our compute from. And I think that when there's competition on that side of the fence as well, we'll see more advancements there. Now, that's not what you were asking about, but I think that will actually benefit us as well, because I think we'll see more faster advancements over there.
So, but however, you did mention that you have, so you mentioned in passing that you have two models, right? One is the chat model, one is the code complete. And you said that for code complete, you were spending like 1 year of experimenting. So those are not experiments on the foundational side of things.
I just think of it as different architectures.
Mm-hmm.
So, I think the world's going to move on to a set of new techniques as well here and new architectures. But ours is the version that we've been playing with for that get us some benefit, particularly for code completion.
So when you say new architecture, you mean like iteration on a transformer, or not a transformer at all?
This one happens to be a non-transformer.
Not a transformer?
Yeah.
In 2024, this is fascinating. Yeah,
I
this
know
is,
that. I know obviously the irony of that talking to Illia here, but I also know some of your experience with that too. You were looking at that as well, weren't you, Alex?
I'm like I was interested at some point in there's a company called Symbolica
Yeah.
that I was talking to, and I was fascinated with what they do. But it's I think theirs is a little bit more far-fetched. At least last time I talked, but I haven't talked to them in more than a year, so it could be that they closer now. Yeah, but I don't think they were in a state to ship something like this year. I don't know. Yeah, but when you say it's not a transformer, and yeah, it's obviously okay if you cannot talk about it, right? But it's is it like is it still like a differential model, like LSTM or whatnot, or is it completely different?
It's not. So these are not like brand new, everything from scratch. Like we're going to publish the paper and we'll be touring on the researcher circuit type of deal. These are things that we all kind of know about, but we're not sure they scale yet.
I see.
And without saying what we're looking at and what we've done, it's things that we said, hey, that's a pretty good idea. I wonder if it will work at this size. I wonder what will happen here. And so that's where we spent our time, right? Figuring out what works from a conceptual level on a paper to something that can scale to a certain size.
Yeah, that's pretty exciting. That's that I would be looking forward to.
Yeah, and I think this is one where in a couple of weeks, you and ISO and I, all four of us should probably catch up on the thing that we've done and what we're happy with and what we still want to iterate on this one too.
But RLCEF, is it on top of the code completion model or is it on top of the chat model?
It's we're using it in both, but primarily the chat model right now. Code completion, we use it in certain ways. We do generate data for it as well. We don't use the complete set for the code completion side. Obviously, as you would expect, we don't use the complete set over there. Primarily for the chat model. And then what we do for the code completion model, I think you guys know our approach too, is we're going to release this publicly for the world, but we're also releasing this for enterprises, which means that we bring it to them. So inside their VPC or data center in that sort of way. So when we do a fine tuning on this, on the system, on their data, it goes into both of them. So the fine tuning happens across both of those models for them.
Also, and in case of enterprise, fine tuning happens on their machines, so you don't see the data.
We don't see the data. That's our promise, and we don't need to see the data because we can generate our way out of the data hole. So we can and so that's again like part of our major investment here is that we're going to invest in the RLCEF because we can generate the data so that we can give the customers what they want. So because no customer is ever going to really send their data over to OpenAI or Anthropic to go do this. They want to have that control, but they really want it inside the systems, inside the model specifically. They don't want to just have it ragged inside there. They want to have it so that the model itself becomes theirs.
Yep.
So maybe zooming out a little bit, kind of would be interesting to talk through how will this start changing the landscape in a broader sense. Like, I mean, we've had this conversation before where you said this is the last wave of technology pretty much to be built because everything else will be built by this technology.
Well, how high level do you want to go? Because I love this conversation, but it's always fun to see how high level people want to go because I can go anywhere.
Now let's go as it gets.
Sorry, what was that, Alex?
As high level as it gets.
So here's a couple of things that I like to net out because I think what I didn't mention in my biography earlier was that I spent a couple of years investing as well at Redpoint and doing.
We're sorry for you.
Yeah, it was. I'm back on this side of the fence. Just put it that way. So and I think there's a reason why I'm also back over here too because I actually feel bad for investors in this moment, and I think. The easiest way I can describe that is because there is a lot of shit that just doesn't matter anymore. Like if you play out 10 years, 15 years, there's a lot of stuff that just doesn't matter. And I'll explain why in my view. First, I think if you really want to distill down what will actually matter in the next 10 years plus type of deal, it's basically electricity, chips that make and run AI intelligence layers. So three things, like electricity, the hardware, chips, and then intelligence layers. And we'll get to intelligence layers in a second, but like you can already see this. You can see why Amazon's buying a nuclear power plant. Microsoft's doing the same. They're investing in all these things. Like electricity is a real big deal. Like I think the state of Texas just said we've got no more electricity for data centers. Like literally today, I think I saw it on Twitter somewhere. Like this is a really big deal. All of a sudden, you know, in my view, electricity is actually, if you think about it from the United States perspective, like this is kind of at the root level. Like we need to be thinking about this because we're, you know, people say, hey, we have enough electricity. Like that's a bunch of bullshit. We don't have enough electricity for what's about to come. We just don't. And then the chips that make and run AI, you know, whether they train and run them, and then the intelligence layers. Now, what I think is going to come, and let me start by saying what my view had always been at GitHub, and it still is today, is that with GitHub Copilot, which is the most successful, in my view, application of commercialized AI, and it's because it's the domain of software, I think it's the most commercializable domain in the moment, is we effectively, when we released it, we effectively started to save developers time. And I think that's one of the best ways to think about this, either save time or gain time. And the first version of GitHub Copilot was all about code completion. And it was saving developers milliseconds and seconds. Then chat came along, we started saving developers minutes to maybe tens of minutes. Then you start to enter a phase where we start to save developers hours or days. And then another way you can think about this is how much time do developers gain in their lives to go do these things. And what's happened is like with the release of GitHub Copilot, we went from every line of code on the planet being human endeavored. And then with the release, we went to dev-led AI assisted, which will quickly give way to AI-led dev assisted, which will quickly just get way to AI-led everybody assisted. Illia, you alluded to this before, like skipping the whole phase of like working in the enterprises and stuff. And that's when, we go from 100 million developers in the world to 2 billion people being able to create and all that sort of stuff, iterate with these things. And, hey, in my parlance, hey, Poolside, create me a Twitter clone. Great, here's 4 running copies. Which one do you want to iterate on? Like, that's a world that's going to exist for people at some point here soon. And the other is going to be, hey, Poolside, do XYZ. Great, here's a couple of running copies of a thing. Like, this one has already passed all your internal check flights from an enterprise perspective. It's all good to go. Let's iterate and make sure that, this is the one that you want to go do. So it's like there's infrastructure underneath these things. So, if you want to say the first 40 years of computing were the deterministic version of computing, we've entered the non-deterministic version of the computing age, and it's all about AI, in my opinion. So I rambled a lot, but I tried to put my thoughts into a box so that we can pull it apart.
Well, I think obviously agree with all of this, but I always challenge to go one step further, because when everybody is a developer or has ability to create software, and I kind of view this more as changing how we interact with computing.
Yeah.
And so when you change how you interact with computing, the interaction itself, like, we don't need software anymore, right? Because like software is just an intermediate state of the computing.
So I have a view that eventually we're going to end up in what I call ephemeral software land. Basically, like, bad analogy, I know what I'm about to say isn't quite work yet, and I'm still trying to sort out how this might look. But I could see a world where we just write software, like source code itself on the fly, and it only persists for the moment in time that's needed to go do a thing. And think of it as almost like a protobuf exchange. Like, you don't care about the protobuf itself, you care about the messages that are being passed back and forth. We already have this with networks, with TCP/IP message passing or UDP message passing, all that sort of stuff. I kind of think we're going to end up down a similar path at some point, not for all software, and not for all digital systems, but a lot of it doesn't need to persist past a certain usage point too. So, like, it's going to be possible to go do. Right now, we don't do it because the cost to do that is so incredibly high.
Yeah, I would split this into maybe 3 categories. There's one that's definitely can be completely kind of temporary, and this is application, like the user interface part, because that can be generated on the fly based on specifically users' kind of context and what they're trying to do. And we actually have a demo of that Alex showed kind of last week at Token, where you just generate on the fly UI for yourself for the actions you want to take or for information you're seeking. And so like as that gets faster, more kind of correct, like shorter time, more context about you as a user. You can imagine that being completely predictive, even where you don't even need to like type in prompt, because it knows you will want to look at whatever stock prices in the morning or like news or something, and just generates that. Then there is a kind of the transformation of AI services, of API services, right, of backends, because they govern some data, they govern some logic, and some of them marshal physical bits, right? Like we still want to eat stuff, we still want to live somewhere, etc. So those will become more semantic, right, where you can like talk to it and kind of interact in more natural way. But at the same time, and this is where kind of what some of the things we're looking at as well, like you want them to actually work within specific set of conditions, right? You don't want it to like accidentally, spend all your money or something. Yep. And so you will need some form of verifiability coming in as well to ensure that the interaction you're doing is actually executing correctly. And so that's where we've been looking at kind of formal methods and specifically Lean to kind of provide user guarantees.
Lean is in, wait, sorry, which Lean?
The kind of proving.
Yeah, the thing in which DeepMind did the alpha proof.
Okay. Yeah. Okay. That one.
There's another.
Yeah. Go ahead. Keep going. I didn't mean to sidetrack you on that one.
No. I mean that's and then there's like a shared state kind of like I bundle them under marketplaces because like it's some kind of shared things that you want to be ideally as global and as open and permissionless as possible, because you want to get either best price or best execution or something, and those really belong on kind of blockchain like infrastructure to be able to facilitate that. And those will be even more permanent and kind of, because like you don't know, like the front end can be generated on the fly, you can talk to it through some AI agents, services, but the marketplace at the end is what provides settlement. You actually getting the apartment, or the food is arriving in whatever, and there's like some facility that actually marshals like as a physical bits or digital or whatever. So that's kind of how I'm thinking, is like a stack of 3 layers that we're going to converge to, where you have kind of marketplaces that have static, like not static, but like the governed shared state. You have API, like AI agent like API services, and then you have kind of dynamically generated applications that now just almost like embed into your operating system to have kind of as much context about you as possible and be able to predict ideally like what is the best experience for you to have. And that's why, to me, like if you look at that future, as you mentioned, like the brownfield seems very not that, right? Because a lot of the software right now is kind of governed, like is about the existing state of shipping monolithic apps and kind of creating like long supply chains of things, because we don't have like global marketplaces. So it is an interesting question of like how that transition will be playing out as this thing's becoming like easier and easier to create.
Yeah, I always go back to working with enterprises and working with individual developers are almost entirely different at the end of the day. And so you have to treat them as 2 different organizations or 2 different groups that you're kind of building towards. And I always think, well, if you're building towards an individual developer, you're doing that greenfield ones. You're doing like, hey, help me get started on something brand new, like their side projects. And then enterprises are, how do I maintain my legacy and that sort of thing. And they're 2 different things. And both of them I think advance, but when you're working with enterprises, the simplest way to say this is like you can't give a spaceship to a caveman. You have to help them evolve along a pathway to show them how to use a spaceship. And but I think I mean I share your view of what the future is going to look like. I think Illia, you and I have talked about this before, but probably the two most influential programming languages for me over the last 20 years and in my youth. One was a weird one called Eiffel, which not many people know about, and the other one was Erlang. And Eiffel had this concept in it, which was designed by contract or programming by contract. And JavaScript has this now in promises and things of that nature, but it's all about, hey, if you enter a function, we're going to guarantee a set of things, and if you exit the function, we're going to guarantee a set of things where we're done. And I think that what you described in your second layer at the API level is actually a lot of what we actually need to go build inside those things, because the way that these things will interact, and the message passing and the mailboxes and the way that Erlang flowed. But the ephemeral interfaces and like those things, I mean, those things are going to be the natural first step. I think that's where we're going to start to see these things, is almost custom UIs for various either surfaces, whether it be mobile or phone, mobile or desktop or whatever. But eventually, like you can think about the algorithmic feed that people see on social as the first version of this, which is it's got a container wrapped around it, but the contents of that change on a regular basis. But the container itself is going to change at some point too, and it'll be ephemeral as well.
Yeah, I think, well, for me, I think the container will just become the operating system, because right now we kind of switching between Twitter, TikTok, Instagram, like it's the same mechanism. It's just like pretty much different walled gardens of content. But either one of the operating systems slash one of these big companies does this, or we're actually going to have an open version. But you can kind of imagine that becoming the operating system, and then you can, from there kind of spawn into more other activities and like issue different intents, right? Be that productive or not. But I guess like bringing it back a little bit, that's kind of one of the things we've been thinking about, and Alex specifically been thinking about, like what are the innovations we need to ensure this correctness of the code? Because the other side of this is like right now we're training all of these foundational models on the code written by people, which we know is highly buggy. And so as we're training these models, they're going to continue producing, as buggy code and vulnerable code. And, as we deploy it in more and more critical systems, that's going to just continue increasing the overall issues in the kind of system. So how do we circumvent that and kind of make sure it's correct by construction?
I mean, I think this is going to be I'm glad to hear Alex is working on it in that way. I think this is going to be an area that really pushes the boundary, because again, going back to like what exists today from a software perspective, people are looking at these things as like, again, code completion and chat. Like, oh, can you do an X for me and I can copy it into my project, or maybe do a greenfield, but you have no idea on correctness. And like in reality, we don't have an idea of correctness outside of post hoc mechanisms today in software anyway. The entire SDLC basically exists to try to help people guarantee a set of things and behavior shape. And in enterprises is about behavior shaping. In the real world, outside of enterprises, it's all about like, does it compile? Does it run? Do I have vulnerabilities? Can I deploy it? All that sort of stuff. But no one wants to do that sort of thing. Like that's should be an artifact of a bygone era at some point in the future. But it's going to take a lot of effort for us to be able to get to that quote unquote correctness, particularly computationally efficient version of that.
Yeah, but I think we have the tools to build code that is correct by construction. It's very tedious to use them, and I mean depending on how we see the slope of AI, it could be that lean proofs will be generated end to end, in a very short period of time, and then it just makes no sense to not only write formally verifiable code.
Yeah.
And I always like using this example. I don't know if I ever mentioned it during office hours. Probably I did, but one of the arguments against formally verified code is that the bugs will just propagate from the code itself into the what you call contract in Eiffel, right? So like the code is formally verified against a set of assertions, but assertions themselves are incorrect.
Well,
right?
I mean, we're always going to end up in a spot where what we asked the system to do was wrong, or we had an assumption that was wrong from a human perspective. Like there's always going to be this human divide to a degree. I mean, again, you could be 100% correct in asking the wrong question, right?
Right. But the beauty is that when you program in Lean and you have a function, or like you have a proposition, and the proposition is not quite what it seems to be, right? So you look at the proposition, and it seems to be that it's saying one thing. In reality, it says another thing. The beauty is that if you don't use the underlying code directly, but instead try to plug it into something of yours that has a higher level proposition, you will not be able to plug it in if the proposition is not actually fitting into the underlying task, right?
Yeah, so I imagine the way this is going to work in the future too is going to be that it's a cold start problem too. So as more of these systems, like what you just said is true, but it's like think of that as an inheritance thing. So it's kind of like the same problem or same way that we've been thinking about writing software for a long time in that way. But also as more systems are written in a way that you can say is robust enough. I'm going to use the word robust. I'm not going to say this, but like you could say verifiable. But the first one's going to be the worst one, and then when enough of those are done and they can interact with each other, then you have a degree of confidence as well. So the confidence value that you have on these things will obviously increase the more that you have there, and the more that they're only interacting with themselves to a degree too. This kind of is the same way that if you think about the way that we built deterministic versions of these things, all the way from the assembly all the way up, is we no longer have to think about a set of systems anymore because they've become robust enough that we can build upon them. And yeah, they still have faults, but it's to a degree, to such a minor degree. In this way here, I think we'll end up in a very similar spot. It'll take years, but like what you're looking at is the very first version of doing that. I'm not familiar with Lean enough to go into like how it's going to materialize the very first time, which is always the interesting one. How does it materialize the very first time that we boot it up there?
Yeah, Lean. I would highly recommend anyone, like both of you and everybody listening, to play with Lean. It's a relatively spiritual experience. To get a little deeper into the weeds. And I think I'm pretty certain that when you code in Lean, you sort of improve the lifetime of the universe, because every time you have a proof in Lean, the entropy decreases of the world.
But I think, I mean, you Alex didn't finish the whole point that like this kind of, if you have proofs all the way down, you actually, as a user now, like from a user level, you can now instantiate the specific conditions, right? You can say like, hey, you cannot spend more than $100.
No. I can put bugs in my propositions, right? But this is a very limited scope, right? Like literally, if my only proposition says, my net worth doesn't go down after executing this transaction, right? Then I know that, like if that one is properly written and I verified it, then it can execute, millions of lines of code underneath. But I know that as long as I didn't mess up that one proposition, nothing bad will happen. So that's
I think I'm going to make that one my number one probably to start out. Then when we're doing these things,
even better, increase net worth.
Yeah, well, I mean, I guess one's the failure case and one's the bear, one's the bull. Like, so you got the exit condition is that I did not go down. I would have liked it if it went up. So
yeah. But like an example would be if the smart contract has a bug that could hypothetically allow someone to withdraw all the money, then what proof the smart contract has then therefore are incorrect, and then I wouldn't be able to plug them into my into the proof of my statement, right? And at the end of the day, I wouldn't be able to invoke it.
Well, again, I think like what you're saying is kind of going back to bad analogy, and I got to go read this in depth and try it out now. Is it's a set of guarantees that someone else is giving me, like, hey, if this exists over here, going back to my Eiffel example, the reason why that was important if you're designed by contract or programmed by contract is that you no longer have to think about certain concerns. And now in Eiffel is all about business concerns, like X and Y. Like, hey, if you entered this function, it means that X was was guaranteed, like whether it be that the person existed or they had a net worth over a certain thing, because you're going to do a credit check. And if they exit, it means you approved. It's an approved function. You approve the credit check, or that type of deal, or maybe not that it's approved, but it's like they have a credit score of this, they have blah blah blah. So you don't have to do any of those sorts of checks. It would feel similar, like, okay, so we build a base set of these things, and we can inherit them, and then we can build more base sets of things and inherit them, build more base sets of things, and you can build upon them all the way through.
Yeah. And the beauty of Lean is that I believe that I might be wrong. I think I read it like in passing somewhere on the web, but I think the Lean compiler itself is formally verified against a simpler version of it. Like they started with something very simple and each consecutive step, but that might not be the case. That might have been about something else. But even if it is not the case, that is something that can become the case in the future. You begin with an extremely simple, very self-contained, verifier, and then you build up from it, so that you know that the actual verifier tool is also correct.
How far are you on this in this exploration at the moment, Alex?
With Lean, we're relatively early. We don't have anything automated yet, and I think this step. There's a couple of interesting steps we're about to take. We're looking into some synthetic data generation, similar to what you were describing. So Lean has a beautiful property that, unlike many other languages, you actually do know if you have the reward. Like Lean compiler will not allow you to compile the proof that does not prove the proposition. Right? So tree search is easier. Like in case of DeepMind, like when they publish alpha proof, it wasn't the problem of the reward. It was more the problem of how do they sieve the actual data on which they do the unrolls. They start with like 1 million of human written problems, and they somehow convert them to Lean. But I think that step, that magic step, is missing.
I mean, we were discussing with Alex actually. So one of the kind of questions of mathematics, right? Like which theorems are interesting.
Mm-hmm.
Right, like which things to work on, which themes are interesting. Given you don't there's no use case yet for it. Like what would be and it's really hard to get use cases for theorems before you actually get them and prove them. Then people can build on them, right? And so the interesting thing here is the interestingness can be defined by how straightforward it is for the model to prove it in the first place.
Yeah. What was the?
No, go ahead.
Yeah, I wanted to clarify, but maybe that's what you were about to say. Yeah, but like if you do like a tree search, right? If it's a very trivial theorem, it will very quickly get to the proof, and if it's very hard, you're just never going to prove. Neither of those is interesting. But for an interesting theorem, it will get to the proof eventually, but it will explore a lot of possibilities. Right. So the bushiness of the tree is what defines the interestingness of the theorem, right? And that is something that is very quantifiable. Right, yep. So you can do the whole search completely unaided by humans by starting, with a set of random simple propositions, and then you just, like your frontier is all the propositions for which the bushiness is high, and then you have a model that proposes new interesting propositions, and another one that is, predicting their bushiness, and then that is another reinforcement learning is training those two. So that's that's a fully.
That makes a ton of sense. It's fascinating from that perspective. I think what I took away, and I really liked what you just said too, is that there's a set of uninteresting ones which are the binary outcomes. Like it's not the fact that it did or didn't. It's where there's the possibility, and this is like where I think a lot of us spend a lot of our time, which is like how do you differentiate when something is inside that bush. I think that's what you're calling it, that set of branches out there. That's fascinating. Okay. So
if anyone in the audience wants to work on that, let us know.
Yeah, I was going to say, that's a fascinating problem to be working on. What do you, and Illia, to your point, until you have a problem for this to be solved, so how are you thinking of even experimenting with this inside a NEAR? I'm assuming you're going to be putting this inside the
we actually have a problem. It's called smart contracts.
Okay, so is it going to be the underlying principle for the smart contract then at some point?
Well, ideally it's through the stack, right? That's what I was kind of saying. Ideally, the user has some set of conditions that then propagate across all of the interactions you have. But in NEAR specifically right now, and in general in blockchain space, you want to have an absolutely correct contracts. You want to make sure that when you're deploying something, it's not going to lose people's money. It's not going to do things that it's not expected. Now, the expectations obviously are defined by a person, and so they may have issues, but this is where kind of this composability of this preconditions can be really powerful, because now other contracts and users can define hey, I will only put my money if it's not going to lose my money in the future kind of condition. And so if that smart contract doesn't prove that it doesn't lose users money, then this condition will fail. And so that's kind of the idea, is we can actually put it on a protocol level almost, where your transaction contains your preconditions, and smart contracts have the kind of the theorems that they postulate. And so it will literally fail, the transaction will fail, or part of the transaction will fail if those conditions are not met. Obviously this is a little bit longer term, but meantime, we need to build the facility for being able to prove these things and generate smart contracts from this.
Yeah. I mean, from a smart contract perspective, it makes a ton of sense. And I would imagine there's a lot of different ways in which you could benefit from this, even if it was just the fact that you want to use a contract. It can prove a set of things, but you can also inherit from another contract, or do another contract, would say, from a security perspective. Let's just say one is a financial oriented one, but one's a security oriented one. And they have to be the composition of the two together for you, or maybe one is a precondition for some other postcondition. I'm just trying to think through live, but it makes a ton of sense there, because what you're trying to do is, with smart contract, is guarantee things.
Yeah, but I think this is going to be obviously very useful for enterprises and everywhere else, because this is kind of at the core that this is the business logic guarantees that everybody wants.
Yeah, I mean, again, going back to the thing that Eiffel, which I don't like to reference. I got to find a better reference for that because no one knows Eiffel. But it's the reason why is that it was so important is because it made it so that programming became interesting again, because you can guarantee things, and that, I think programming is interesting when you can guarantee pre's and posts. So
yeah, no, you will have. You said you had two languages that made you experience spiritual.
Yeah, that was. I mean, so. The name more than Eiffel and Erlang.
Yeah, I think that number is about to bump to 3.
I feel like now that what you're talking about here is I might be going down a rabbit hole where ISO is just going to be stop talking to me about this right now. We have to actually serve customers. So.
All right, I think we're over time, so I really appreciate you coming in. Hopefully people learned more about Poolside, as well as our kind of general conversation on AI developer and repercussions of that coming. So thanks, and see you all next time.
Thanks, everybody. Good to be here.